All right, so in this section, we're going to talk about sampling, everyone's favorite subject. So Redshift has, if we go into the render settings and look under Redshift and check the basic tab, we're going to see this drop down for unified sampling. And this is one of the main optimization principles about Redshift, is that essentially it's going to look at samples min and say, okay, cool, we're at least going to fire 4 camera rays per pixel, and we're going to keep firing more rays up to my samples max, which is 16, until we think we've found a grainless solution. But if we don't need to get up to 16, then let's just stop at whatever number of rays is good enough to satisfy this adaptive error threshold. Now, it's important to understand that unified sampling is actually only controlling directly the camera rays. However, depending on how we have our samples max set, and depending on how all of our other samples are set, we're also going to be controlling our secondary rays with our primary camera ray count. So to get a better idea of how the unified sampling works in relation to our secondary rays, such as reflection, refraction, ambient occlusion, etc., let's take a really simple look at just one ray striking a surface and what might happen there depending on how we have our unified samples set up. So let's just say for a second that this red sphere is our camera and the gray line is a surface. So in this scenario, we're only going to start with one primary camera ray. Let's imagine that this sphere is our camera and the gray line is our surface. And right now our max unified samples are set to 1. At the same time, let's say our reflection rays or brute force GI rays we have set to 4. So that means for every pixel, we're going to send one primary camera ray, and we're also going to send 4 secondary rays. So we end up having 1 primary ray and 4 secondary rays. Now, let's say I keep the same number of reflection or brute force GI rays, let's just say secondary rays. My sample setting for my secondary ray set to 4, which is way lower than we'd ever use, but for this example, it'll work. And we're going to increase our max unified sampling up to 2. So what that's going to do is it's going to divide my secondary rays by the number of the max camera rays that we have set. So in this case, my new max is going to be 2. So instead, we get 2 primary rays firing from the camera. And those 4 secondary rays we had are now split into 2 and 2. 2 divided by 4. Now the tricky part comes in with the unified sampling, because let's say our max is 2 and our min is 1. If as Redshift is rendering, it sees that it only needs to use one of the primary camera rays instead of firing both, that means we'll end up only having used 2 secondary rays. And just to super slow that down, we'll just step it through one by one real quick. So we send our picture to render. We press the render button. Redshift starts rendering. It's going to start at the lowest number that you've entered, which in our case is going to be 1. So we fire 1 ray. We have set 4 secondary rays, and our max primary rays are 2. So we're going to do 4 divided by 2, and we'll get our 2 rays. Now in some cases, this is going to be enough information in the image for Redshift to say, cool, we don't need to send any more rays. But in harder to trace areas with more expensive calculations that need to be done for less grain, Redshift may say, hey, whoa, that's not enough. We need to keep sending rays. So we're going to send our second ray with our second batch of secondary rays. And now we've hit our max. So that's it. We're done. Return the pixel as it is. That's essentially how all of the secondary rays will get divided across our unified sampling. So if we have our reflection samples set to 16, and our samples min is 4, and our samples max is 16. Well, 16 divided by 16 is 1. So for every primary ray that gets sent, we're going to send 1 reflection ray as well. Now, let's say for refraction, I have 32. So we've got 32 divided by 16 is 2. So that means for every additional camera ray that is sent, we're also taking 2 refraction samples or firing 2 refraction rays. And this works the same way for all of the different events that we can sample, including our subsurface, volume lights, AO, refraction, reflection, and GI. Something else to keep in mind is that it's always better to have more samples in the secondary ray types than it is to have in the camera rays. For example, if we take our reflection lobe and say we're going to give you 8 samples, well, so we're going to take 8 and divide it by 16 and get 0.5, which doesn't make any sense. We can't send half of a ray. So Redshift is going to send 1 ray of reflection sampling per camera ray. And that could actually get pretty expensive because let's say we have a scene where our samples min are 4 and our samples max are 256. And let's say our reflection rays are 128. That means Redshift is going to be sending a new camera ray basically for every reflection ray until it hits its error threshold quota and stops firing rays. Whereas, let's say if we had set our reflection samples to maybe 512, whoops, that's 521. 512 or even 1024. Now we're sending 4 reflection rays per camera ray. So let's just say on random pixel here, it's a really expensive pixel and it's actually going to take most of our reflection samples for Redshift to say, okay, cool, we've met the adaptive error threshold. Let's move on. If I had my reflection samples set down to something low like 128, I'd actually have to drive up my max unified samples all the way up to 1024 to get that pixel to clear up. And it's way more expensive to send camera rays than it is to send reflection rays. So the takeaway here is don't skimp on your secondary rays, because the higher your secondary rays are, the faster the unified sampler is going to get to a satisfactory result. So with that in mind, let's take a look at the scene that I've set up here. And we'll just quickly go through and talk about some ways to attack your scene for cleaning up your grain with the various sample settings. So I've got a pretty standard Cornell box here with a 50% gray diffuse orb in the back left, a refractive orb in the front center, and a perfectly reflective material with a little bit of roughness on the back right orb. I have not turned on GI, and I've just left my render settings completely at default. So let's go ahead and take a look at how we would go about cleaning up this grain. So the very first thing I would start with are taking care of your lights and the light samples. So if we zoom in here, and actually before I move on, I just want to mention that whenever you're doing final render optimization, you want to be using the bucket rendering mode, as that's actually going to calculate the final pixels for your scene. In most cases, things like motion blur, for example, you'll actually have to render in order to see, but we'll talk about that later. All right, so let's go ahead and tackle this scene. I don't have GI turned on right now, and I only have one light in my scene, and it's this overhead light. So as we look at this grain, we can rest assured that it is definitely coming from this light. But before we go and dive in any further, let's go ahead and set our samples min and samples max to 1 and 1, which means no matter what, for every pixel on the screen, we're only going to fire 1 camera ray. So any adjustments we make to these secondary rays or our light samples or whatever, we know we're seeing directly the effect of that. Now, one consequence for doing it that way is going to be that our edges are going to be kind of jacked up and jaggy looking for now, but we're creative individuals. We can see the light at the end of the tunnel. I'm sure we'll make it through. And we will end up adjusting the unified sampling at the very end. So for now, I can see we've got a bit of grain on the walls themselves, and we definitely have grain in the shadows, which are both the light sample's responsibility. So we can get to that by clicking on the area light and scrolling all the way down to the bottom, and we see light samples down here are set to 16. Now, we can either adjust samples for the lights down here on our lights individually. In the case where your scene has only a handful of lights, that can be just fine. We also have the option to go into the sampling overrides and just control all of our lights samples through those overrides. So actually for this demonstration, I'm going to use the sampling overrides, but I'm also going to show you in each case where you can find the sampling controls for the various lobes. So let's look at lights. I'm going to go ahead and tick override samples for lights, and let's take a look at where we're at. We're exactly the same spot. So let's just start doubling this guy up to 32. We can see our shadows are clearing up a little bit. 64. Let's keep going. 128. Maybe keep going. 256. Starting to get there. Let's check our walls. Looks like those are pretty grain free. Although I am seeing a little bit up there. Maybe let's just double it again just in case, up to 512. Because it's better in this case to have a few more samples in our secondary rays than it is to have to compensate with unified sampling. All right, so that's looking pretty good. Next, let's go ahead and add GI in. So we'll flip over to the GI tab. And in this case, I'd like to use the brute force method for my primary GI engine. And I'm also going to set up a secondary GI engine as the Irradiance Point Cloud. Now, if you'd like more information about these, you can go ahead and check out the Global Illumination section. But these are the guys I'd like to use for my box here. So, same scenario, except we also are going to have this samples per pixel for the Irradiance Point Cloud, though it's not quite the same in terms of diagnosing grain. So let's go ahead and flip our brute force GI rays up to 32. And just zoom on in here. You can see we're still pretty grainy. Dial that up to 64. I'm going to go ahead and jump up to 256 because I don't think that looks like 128 would catch it. Now we're starting to get somewhere. 512. It's nearly there. Let's go take a look at our other corners and see how those are looking. Pretty good. How are the walls looking? Fairly good. Might be able to use some more. Let's go ahead and dial this up to 1024 just to make sure we're completely free of grain. There we go, looking pretty good. So now we've got our GI rays set up. Let's go ahead and flip back and handle our reflection rays. Now, for this, we can actually dive into a per material option if we like by flipping into the Redshift material itself, going under the reflection tab, and you'll find samples nested in the reflection tab. But in this case, we're just going to continue to use the reflection overrides. So let's go ahead and take our samples, and this is highly unacceptable. So let's just start off at 128, and then we'll double it up from there. All right, that already looks quite good, but you'll notice in our black space out here, it's actually still rather grainy. So if I dial this up to 256, let's see how that looks. Still kind of grainy. Now this is probably because this is a GGX material, so we're getting actually quite a bit of fall off across what would otherwise be just a perfectly black hole there. So let's dial up to 512. Pretty close. I think we're gonna just go ahead and land at 1024 again. All right, that looks pretty clean to me. And lastly, let's take a look at our refraction. I don't really see much in the way of refraction issues here. Or at least if there are, it's going to be hard to tell without turning my unified sampling on. So for now, I'm going to leave refraction off, and we'll go take a look at that after we start to kick up our unified samples. So in this case, we don't have any motion blur or depth of field. So really, we only need the unified sampling for two things. One, to give us anti-aliasing around these edges, and two, to try to help us optimize the scene a little bit. Because right now, we're throwing all of these rays from our secondaries at every pixel. And it's very likely that we don't need to do that for every pixel on our screen. So why don't we set our samples min to 4. So no matter what, we're always going to send 4 camera rays into the scene. And let's start our samples max at about 32. Now you can see we're blowing through there pretty quickly. Although now we are starting to see some grain. So we're going to need to dial our sampling just a little bit to see how we can help that out. So one guy that can help us out with this is the adaptive error threshold. And what that's going to do is make Redshift a lot more snobby about grain. So the lower the adaptive threshold is, the harder Redshift is going to look for grain, and therefore tend to send more camera rays than it would have with a higher threshold. Whereas with a higher threshold, Redshift is like, okay, cool, that's good enough, move on. and you'll end up seeing, quite a bit of grain. So I'm going to go ahead and set the adaptive error threshold down to 0.001. And then I'm also going to go ahead and tick on this show samples box. Now, what this is going to do is give me a black and white image where darker tones represent less camera rays fired and brighter tones represent more camera rays fired. So you can see here, actually, we've got quite a good amount of contrast, which is what we're looking for. So I'm going to go ahead and untick show samples. And let's just go ahead and take a look at those corners. This is probably solvable by doubling up our brute force GI rays. And there we go. So now you'll notice that when I saw the grain in the corner, I didn't just go to unified sampling samples max and start cranking that up, because ultimately that's not going to be the solution. The reason for that is we really needed more brute force GI rays. So if I had left brute force GI rays at 1024 and started bringing up samples max, here's the effect we would have. Right now we've got 32 max samples and we've got 1024 GI rays. So 1024 divided by 32 is 32. So right now for every one camera ray that gets used, we have 32 GI rays. So if I take my samples max and up that to 64, it's not going to change my number of GI rays. It's only going to give me more camera samples, and then divide those GI rays across 64 camera samples, which means now every camera ray has 16 GI samples in it. In fact, we would have to go over our number of brute force GI rays with our unified sampling max in order to start seeing that grain cleanup. Because when our unified sampling max is higher than our GI, it will be rounding. Let's say we would have 2048, right? So that means for every ray, we would have 0.5 GI rays. Again, you can't have half of a ray, so that means for every camera sample that we send, or camera ray that we send, we would be sending 0.5 rounded up to 1 camera rays. So once the unified sampler got up to 1024 camera rays and went to 1025 camera rays, then we would have more samples than what is entered in our brute force GI number of rays. But we don't need to do that. All we have to do is set 32 here and double our GI rays. So you might be thinking to yourself, well, 4 and 32, that's pretty low. When am I going to need more than that? And the answer to that question is when you're using either motion blur or depth of field. And depending on how much of those effects you're using, the unified sampling samples max may have to get pretty high. So let's just take a look at an example of that really quickly and see what that's all about. All right, so I have a version of the same scene, except the refractive ball is animated, just going up on the y-axis. I've also added significant depth of field, and I've kept our sampling exactly the same values. So let's go ahead and zoom in and take a look at our depth of field here. You can see that our blur is quite grainy, and that's because Redshift needs more camera rays in order to solve for this depth of field issue. So when dealing with depth of field or motion blur, you would use the same principle that we talked about earlier, where you would set your secondary samples up first and then get a clean unified sampling setting, then flip on your depth of field, and we start cranking these numbers up until we get satisfactory results. And if I'm being brutally honest, it just takes more camera rays. Now again, this is a really, really drastic example. You can see my wall here is only in focus in just this little sliver. But if we take this up to something like 512, see it's going to take a second, but you can see that our edges now are quite clean by comparison. Now that pocket that we had earlier that was giving us a little bit of trouble up here in the corner is also giving us a little bit of trouble now, but I suspect that has to do more with the camera rays than it does with the GI. Our GI is the same setting as it was in the other scene. I'm going to go ahead and up this to 1024, and let's see what our result looks like. As you can see, it just continues to smooth everything out for us in our depth of field. So Let's go ahead and talk about motion blur for a second. I'm going to disable our depth of field, and I'm going to set our unified samples max back down to 32. Now, surprisingly enough, I actually already have motion blur enabled, but we're not seeing it in the render view here. And that's because we actually need to turn the render view off and just press render. So I'm just going to go ahead and press Shift R for render. And again, this is a pretty extreme example, but I just wanted to show how we can go about dealing with this. So, pretty extreme grain there because we've got some pretty extreme motion blur. So I'm going to start actually with a pretty giant leap up to 1024 max samples, and we'll press render again. And there we go. It looks like 1024 is about what it needs to be for this grain to clean up. I'm going to go ahead and set it down to 512 just so we can see what the step below this would look like. We can see that we're getting at 512 samples, a bit of grain in this long streak here, and definitely a lot of grain from what is our refracted light in the bottom of the sphere here. But again, this is a pretty drastic example. I just wanted to show how you would clean something up like this up using the unified sampler. Now, I just want to go over a couple other options really quickly before we close out, and that is the Don't Automatically Reduce Samples of Other Effects button. Now, I really don't recommend using this, but basically what it does is instead of dividing our 1024 reflection samples or any other secondary ray samples, dividing that across our samples max, it's going to give this many samples per camera array. So in this case, instead of having max samples of 1024, it would be closer to 500,000 samples per pixel. So at that point, you might as well be using CPU rendering. Ba-dum-cha. Just kidding, I love CPU render engines too. Just a couple other options of note. Under optimization, we have maximum trace depth. And what this is going to do is give a limit to how many times a ray can be reflected or refracted. A good thought experiment for reflection is imagine two mirrors facing each other. Reflection trace depth was set to 4. You would see 2 copies of the image reflected on either side, and no more than that. Similarly with refraction, if we had a line of 10 orbs, if our refraction maximum trace depth is set to 6, we would not see the ray contributions all the way to the end of those 10 orbs. Although it might be difficult to see anyway, they wouldn't be traced. The combined maximum trace depth is kind of interesting. So let's say our ray is reflected 4 times and our combined amount is set to 6. It can only be reflected or refracted 2 more times before it's terminated. This is just a good one to know because you may run into it when setting up many different reflective or refractive scenes that have more than one object that has either a reflective or refractive surface. All right, well, thanks for checking out the sampling section. I'd highly recommend that you also go take a look at the GI section right after this, because in that section we go more into depth on camera rays and sort of visualize what they're doing. So if this was a little difficult to understand, go take a look at the GI section and then come back and take a look at this one. And we'll see you in the next one.